So we're now going to take a look at another example. This is example EX23, which is in my Java 8 folder in my live lessons GitHub repository. I'll put the link out when I put the video out. And this example basically shows the difference between calling join on many intermediate completable futures, which will block and therefore degrade performance, versus just making a single call to join, which will enable greater parallelism. And this is basically trying to show why join is problematic and you should use it very sparingly. We just really need to use it one time in this example. So let's take a look. We start out with an atomic integer field called mCounter, which starts at 10 for reasons that'll become clear when we look at what the results look like. And then we make ourselves a supplier, which is called mSupplier. It should probably actually be called sSupplier because it's a static, but I'll just fix that later. And what mSupplier does is it increments the counter by 1, and then it displays what the value is, and it sleeps for a second, and then says, I'm out of here, and it returns that result. Okay, we also define another field called maction, which is going to take an integer, and it's going to print the value, and then it's going to do something really funky. If the value modded by 2 equals 1, in other words, if it's an odd number, it'll return that value. But if it's an even number, it's going to return null, which seems like a strange thing to do, but you'll see when we do the test why we do it that way. So those are the two fields, mSupplier and maction. We then come down here and we make ourselves a list of suppliers to integers, which is just a list of calling mSupplier, mSupplier, mSupplier 6 times. And if you call mSupplier, every time it's called is going to increment the counter by 1 and then sleep for a second. So we're going to go ahead and have a bunch of those things put into a list. And then we're going to do 2 timed run calls. Remember, time run is this little helper method that I've shown you many, many times, which takes a runnable, starts the timer, runs the runnable, stops the timer, and then stores the time it took to execute under the name in a private results map. So we're going to time something called test many joins, and we're going to time something called test one join, and then we're going to print the results. And as you might expect, the one that does the one join is going to be a lot faster than the one that does the many joins, for reasons that will become clear when we look at what these methods do. So let's go take a look at test many joins first. So test many joins is going to take that list of suppliers of integers. Remember, their basic purpose is to increment a counter, print a diagnostic, and then sleep for a second. And for each of the elements in that list, we convert them to a stream. So we now have a stream of these suppliers. And then we're going to basically take each of those suppliers to integers, and we're going to call supply async on them. So we pass in the supply async method reference to map, which means we will end up with a stream of completable futures to integers because that's what the get method returns. And then what we're going to do, because we're going to show how you can use, or how filter is limited when dealing with completable futures. Filter doesn't know anything about completable futures. It only knows about predicates. And so if we want to be able to do filter here, we're going to have to say the future, because we get back a stream of futures, then apply the action. And remember, the action is going to basically return odd numbers and then return nulls for even numbers. But for this to work with filter, we need to call join, which means it's going to block. And what happens then is if join does not return null, then we're going to let it go through, and we're going to end up collecting the results into a single completable future, which will then go ahead and trigger when all the computations are done. Now, the problem here is that there's really nothing asynchronously going on here because we've been joining everything. And so it'll block and be very slow. When we're all done, when this future that comes back from collect triggers, we call then accept async, which will run in the background. And we're going to call the display primes method. And display primes is going to take the list of integers, turn it into a stream of integers, get rid of non-prime numbers, and then convert the integers to strings, and then join them all together, and then print the results. So we're going to get the list of primes. And that's why we only let odd numbers through, and we give nulls for non-odd numbers because we were going to filter them out. Okay, and then when we're done, we also call join for that to wait until everything is done, and then we leave that test. So that's testing many joins. Let's now go ahead and take a look at test one join, which is going to do sort of the same thing, but it's only going to have one join, and it's going to be a lot more asynchronous. So what we do in this case is we take our list of suppliers to integers, turn it into a stream of suppliers to integers, and then we're going to use the supply async factory method as a method reference to map to go ahead and run each of those suppliers asynchronously, just like we've done before. But the difference now is what we're going to do is for each of the completable futures to integers that comes out of map, we're going to apply map again, and it's going to say, wait until the completable future is done, and then apply the action. And notice that there's no join here. Number one, we're using map, not filter, whereas up here we'd used filter, so we had to join. So this is just saying, whenever this thing is done, apply the action. And that'll return, of course, a completable future. We then use our stream of futures collector to return a single completable future that will trigger when all those asynchronous calls are completed. So now they're all going to run in parallel, whereas before they were running by blocking and they were running synchronously. And then when we're done, we're going to call then accept async like we did before with the stream of results. And notice we're having a stream here, not a list. So we have stream of futures collector. And we take the stream and we filter out non-null results. So we only have the prime numbers basically left. We collect those up into a list, and then we go ahead and display that list. And we block only one time here in join. So when we run this program and we go look at the results, you can see what happens. Notice how the test many joins method is going to basically run these things in lockstep. So everything is done one after another by blocking because they're all calling join. We're joining many joins. There's many calls to join. And you can see how that affects the results. And at the end, we ended up with 2 prime numbers. In contrast, test one join starts everything up in parallel. And so you can see that we have 6 things all starting up at exactly the same time. And then as those things finish, then they are completed and the results come back with whatever values are. And again, we get some primes. What's interesting here is the time. So this is what you'd expect if you think about what we did. For the test many joins, we slept for a second synchronously. And since we had 6 things we were running, then it ended up taking essentially a little bit over 6 seconds because everything was blocking synchronously. In contrast with test one join, everything went off in parallel and slept in its own thread in the common fork join pool. And all those things slept for 1 second, then returned, which triggered the collector to return. And then we printed the results. And so it took basically just a tad over 1 second to run all those computations because they all ran in parallel. Whereas with the other one, we ran everything synchronously. So this, again, just kind of illustrates the main point I'm trying to emphasize here, which is if you do things with completable futures and you restrict your use of join to the bare minimum, which is what we did here, you're going to get a lot more effective parallelism than if you end up having lots of calls to join, which impede the parallelism. And this also, of course, illustrates how you can combine completable futures with Java streams, in this case, Java sequential streams, to good effect. And you can get nice synergy where the Java sequential stream gives you the structure of the control flow through the application without requiring loops, without requiring if statements or switch statements and so on. And completable futures give you the ability to run things concurrently in a pool of threads coming out of the common fork join pool.